Hi Spring fans, welcome to another installment of SpringOne Tour. We've got an exciting show for you. I'm your host and producer, Spring developer advocate Josh Long, and today's installment is going to dive deep into building a pipeline to production. We're going to look at testing Spring Boot apps, continuous integration, and continuous delivery. There's a lot to cover, so it's fortunate then that we'll be joined by our friends on the Spring and Tanzu teams to help us out in our journey. We've got our special guest star, fellow Java champion and developer advocate at Apply Tools, Angie Jones, the queen of test, and my go-to for all things testing. Of course, we'll need a domain, and we've decided it should be cats, because the internet was made for cats. Let's get the ball rolling. I'll be pair programming with Madhura Bhave to learn the basics of testing.
In today's session, we're going to be talking about testing. Specifically, we're going to be talking about testing your Spring Boot applications. Hopefully, all of you already understand the benefits of testing your application. It not only gives you the confidence to push your code to production, but it also lets you refactor things and make changes faster while ensuring that you aren't really breaking existing functionality. We're going to be using TDD, or test-driven development. TDD is something that I personally really like, and I use it on a daily basis. It helps me make sure that I'm testing the right thing. We'll be using red-green refactoring. So we'll write a test that fails first, and then write just enough code to make that test go green. When you're thinking about structuring your test suite, one thing to keep in mind as a general rule is the test pyramid, where the bottommost part of the pyramid, which is the biggest part, is what represents your unit tests. So you'd have a lot more unit tests, and for a Spring application, that means that those tests wouldn't involve any Spring. And because unit tests are faster to run, that's where you'd have tests for edge cases and things like that. The middle tier would be where you do involve Spring, but it's not necessarily the entire Spring application context. So they're still faster to run than a full integration test. So you'd have more of these middle layer tests than integration tests in your test suite. And the topmost layer would be the full integration test, where you have the entire Spring application context running to make sure that your application works end to end. There's a couple of ways of doing TDD. You can do inside-out TDD, where you start from unit tests, and then as you develop your application, you move out to the integration tests. And there's outside-in, where you start from a failing integration test, and then you build out the components, write unit tests for those components, and then run the integration test to see that it passes. In today's demo, we'll be using the inside-out method. So we'll be starting with our unit tests first, and then moving on to the full-blown integration test. Joining me today is my colleague Josh. Josh is also on the Spring team. He's a Spring developer advocate, actually one of the first developer advocates on the Spring team. And we will be pair programming together on the application that we're building.
So we're going to start off with our application, which is a cats application, because I was told that the internet is all about cats.
That's a fact. That's true.
Okay, sounds good then. Let's go with a cats application, and we're going to use Start.Stringer.io, obviously, which I've heard is your favorite place on the internet.
Second favorite place.
Second favorite place, right?
Did you hear that Tim Berners-Lee, the Sir Tim Berners-Lee, I think, who is credited for having created the internet, he just sold the source code for the internet, basically. He sold an NFT for the source code that created the internet.
Did it have cats in it?
I don't, I was kind of looking at the item description, and there's no mention of being the ultimate platform for cats anywhere in that initial document, but I'm sure he was just playing 12-dimensional chess, and that was actually his long-term plan, was to make this the ultimate cat form.
Yeah, I think you're right. So with that, let's rename our artifact to cat or cats?
I'm all about more than one cat, so plural if we can.
Okay, let's do that. cat service. So a quick look at the dependencies that we just added. We're building a web application, so we need Spring Web. We need to be able to persist our cats in a database, so we're going to be using Spring Data JPA. PostgreSQL is the database that we want in production, and H2 is an embedded database that we want to use for our tests. So that we have the zip file, we can unzip it and import it into IntelliJ. There we go. So we've got our basic skeleton app from Startup Springer.io into IntelliJ, or you can use any IDE that you like. And all the dependencies that we added from Startup Springer.io are present in our form. The Spring Boot starter test wasn't something that we explicitly added, but Initializer, or the backend of Startup Springer.io, did add it for us because testing is super important. Hopefully, you all agree with that. And the Spring Boot starter test is going to give us a bunch of other dependencies that are convenient when writing tests.
How do we approach this?
So we're building an application about cats, right? We're basically going to be storing some cats in the database, and the first thing that we want to be able to do is fetch a cat from the database using a REST API by name.
Oh, cats don't play fetch. They are not fetching creatures. So it's fitting that we will fetch them for a demo.
Yeah, got it. I think Josh is here just for cat jokes. I'm just gonna hope he also helps me with some of the code that we're pair programming on today. So there is this basic test that you get when you generate an app from Startup Springer.io. Basically, it just checks that the context loads and it starts up fine, which is fine to begin with, but not something that you want to actually. We probably want something more when we're testing our production code.
Yeah.
I'm just going to go ahead and delete this test. And before we do anything, we need an object for a cat. So we need to define what a cat is. And before we add code for a cat, we're going to add test for a cat. So this is going to be a simple unit test, not involving any string at all. All we're going to do is we're going to say that adding a cat, or creating a cat rather, with a valid name. Valid cat does not throw exception, right?
Mm-hmm.
And if you look here, this class over here isn't public, and neither is the test method. That's just something nice that you can do with JUnit 5. Things don't need to be public unless they absolutely need to be public. So you can have matched private test classes and test methods because we're using JUnit 5, which you get for free with Spring Boot Starter Test. So here's our class for our cat tests. And if you look here, it's not public, and that's because it's going to be a JUnit 5 test, and that's what you get. JUnit 5 is a dependency that Spring Boot Starter Test pulls in. And the nice thing about it is that you don't need your test classes and test methods to be public. So because this is a simple unit test, we can write a bunch of edge cases here, tests for edge cases here. So I guess the first test that we want to write is that cat with lowercase name should throw exception, because I've been told that the cat's name should start with an uppercase letter.
It's only decent.
That doesn't happen. We want to say that assertions, and we're going to be using assertions from assert_j. Again, this is something you get for free with Spring Boot Starter Test. You don't need to worry about maintaining the version for this. And assert_j gives you a nice fluent API with convenient methods for asserting that no exception was thrown, or rather, in our case, that an exception of type illegal argument exception was thrown when a new cat is created with a lowercase name, with a name that starts with lowercase. But before we run our test or do anything, we don't have
Cat.
A class. We don't have cat, so we need cat.
Okay, so a test that doesn't compile is a failing test. And so even though it's not business logic just yet, even the act of making your test compile is actually production code, so I will handle this bit. So we want a cat that has a constructor that takes a string for the name. So there's our constructor and our field.
And now we can run the test. So yeah, we expected this test to throw an exception, but we didn't get one.
I should check that the first character is uppercase. So I'm going to do is true, and I'm going to use the first character. I'll say character at 0, and I'll just ask character dot is uppercase, and if that doesn't work, I'll bark the first character.
You mean meow, right?
Meow. There you go. You're right. I should have meowed. The first character of the name must be uppercase. And here I'm using a class called assert, but that's actually a class in Spring, and this is more of a design by contract kind of use case, not a unit testing use case. So if we return back to our test.
Yeah, go back to cat test and run it again now that we've added some code to see if it passes. There we go, got a green test. So we were testing the right thing. We're making sure that the exception that we got is related to the code that we just added.
Awesome. So we've got a basic class, but that's, we have to persist it, right?
Yeah, I mean, there's no point in just having a cat. They need somewhere to live. So before we add the main source code, we're going to add a test for cat JPA test, let's call it.
Okay.
And this is where we're going to be involving some string. So far the cat test was a pure unit test. There was no Spring Boot, no Spring Boot application context in there. But again, like this cat JPA test is a very specific test. We just want to be testing the database layer. So we're going to use Spring Boot's data JPA test slice. So test slices was something that were added in Spring Boot 1.4, and they let you start up your tests with a very specific part of Spring Boot's application context. And in this case, it's the data layer that we're testing. So we use data JPA test. There's a bunch of convenient themes that you can auto-wire to be able to test your database layer. So the first thing that we want to test is that we can persist a cat in the database. And for that, we're going to be auto-wiring the test entity manager, which is a flavor of entity manager that can be used in tests with some convenient methods such as persist, flush, find, and some more. Okay, so let's say that cat can be saved or persisted. And let's say that this.entity manager persists new cat Toby. Yeah, we're always going to go with a cat named Toby. And then again, we want to use assertions from assert J and say that no exception is thrown when you try to persist a cat in the database. Okay, so let's run that and see if it works. So as you can see, like it's starting up the Spring application context. You could see some of the Spring Boot banner in the logs. And the test fails because it says that it didn't expect an exception, but it got an exception of unknown entity.
Okay, so I need to change this object so that it's more of a JPA entity. And as far as I know, the way you do that is by adding the entity annotation. It will complain, it'll meow that we also need an ID. Is that true?
Yeah, so if we do run this test, do you want to try running this test one more time?
Yeah, sure.
To see if that fixes it? Okay, but it's still not working, and that's because it's complaining that this cat doesn't have an ID.
Okay, so we saw that coming, but it's okay. Let's
Yeah, the reason why we run our test every time after adding a single line of code is because we want to make sure that we're testing the right thing, and that every line of code that we add, if removed, would cause our test to fail.
It's a constant loop. You're constantly ping-ponging back and forth, from one side to the other. In a larger monitor, you might even have like this split screen, or different. You'd have the code and the production code, the test code and the production code side by side. And so
typically, like when pair programming, you'd even have two different monitors. So
yeah. Okay.
Right. So we can persist our cat now, but we also need to be able to get it out of the database once it's persisted. And I think we can do that with a repository.
Yeah.
So let's say that we have a cat repository, which we don't have yet.
Okay.
So let's make our test compile.
Gotta make our test compile. Okay.
Okay, that was good enough to make it compile. Let's write the actual test for. We want to be able to find the cat by name and make sure that it returns a cat. So before we can assert that we get the cat out of the database, we need to set up this test so that it saves the cat. Looks like there is no save method of the cat repository.
Okay, I think we can get that one for free just with the Spring Data repository interface. So we'll say extends JPA repository for types of cat whose primary key is of type integer, and this becomes an interface, and we just it gets implied automatically.
Nice. So we get the save method for free, and we say we want to save a cat named Toby, and then we can assert that when we try to get this cat out of the repository using a find by name method, oops, looks like there is no find by name.
Okay, so I can handle this. This is one of the nice things about Spring Data interfaces, is that you can just declaratively define a finder method, find by name, string name, and then based on convention, it'll automatically provide an implementation.
Nice. So it takes a string, so we're gonna say find by name Toby dot. It returns a cat, right?
Mm-hmm.
Find by name. So I should be able to say dot get name. Oh, looks like we haven't added a getter on the name.
Aha. So we'll go back to the cat. And we need a getter. Okay.
Thank you. Is equal to Toby. Let's run that.
Cool.
Nice. So we didn't actually need to write too much code. Spring Data pretty much handled a lot of it for us. The only thing that we did need to test is that we have this find by name method, which takes in the right argument and gives us a cat back.
So the first test was to test whether we had the valid mapping so that it could round trip to a JPA session, through a JPA entity manager. The second test was more to test the custom finder method. We don't need to test the save method because that was written by the Spring Data team. You know that works, right? So long as you have a valid entity.
Yeah, exactly. So now that we know that we can save some cats, get some cats out of the database, someone should be able to somehow get access to these cats, right, from the database. So what should we do?
I think if you write data to the database and there's no REST API by which to read it, did you actually write it so we need a REST API controller of some sort.
Okay, and before we write your REST API, we need to write a test for it. So it's going to be a controller test. And again, we're using another test slice from Spring Boot. It's going to be the web MVC test. So this is because we're just testing the web layer at this point. We don't care about the other parts of the application. And with web MVC test, we can auto wire mock MVC, which can be used to test our controller. So let's say like get name should return. Sorry, get cat with name should return cat. And then we could say mock MVC dot, we perform a request to mock MVC request builders dot get to cats. That's going to be our REST API. And the path variable name. Of course, we're going to stick with Toby. And we're going to expect that the status is okay. I think along with the status, we should also assert on what the content is, right?
Yeah.
That gets returned from the API. So let's set up some expected content that we expect from the API. And for that, we're going to use the object mapper from Jackson, which also gets auto-configured for a web MVC test. So we can say this object mapper dot write value is string new cat Toby, and both of these throw an exception. So let's add that. So this is going to be our expected value from the REST endpoint. I think the controller needs to also be able to get the data from somewhere. So we need to tell it that you need to get the data from the cat repository. But because this is a web MVC test and we're not really testing the data layer at this point, we already have a separate test for the data layer, we can mock out the cat repository. So we can do that using the mock bean annotation, which is Spring Boot's support for Mockito. Mockito is the mocking library that you get with Spring Boot starter test. And what mock bean does is that if there is a bean of that type in the application context, in this case, cat repository, it will replace that bean with a Mockito mock. Or if the bean doesn't exist at all in the application context, it will create a bean for you. So we can stub out the behavior of the repository, and we want to tell it that when the repository's find by name method is called with Toby as the argument, it will return a cat. And then in our assertions, we can go ahead and expect that we get, let me add a static import, expected cat value. Good enough?
Yeah, looks good to me.
Okay, so it failed as expected because we don't actually have our controller written. So instead of a 200 HTTP status, we get a 404 not found.
Okay, that's my cue. I need to write a quick controller here. So we want the cat REST controller, and it'll be at REST controller. And get mapping cat's name, cat by name, path variable, string name, return. I'm going to need the repository, so I'll inject this.
Mm-hmm.
And we'll have to synthesize a constructor there. And this dot repository dot find by name name. All right, that looks like it'll do.
There we go. Let's run the test. Okay, there we go.
Cool.
The test is green, which means our REST endpoint works as expected. So we've got all these different bits and pieces of the application tested out now, but we should definitely make sure that they all work together. And for that, we need an integration test. Let's go ahead and write a cat integration test. So we're going to be using the Spring Boot test annotation, and that will basically give us the entire Spring application context with all of the beans present in the application. The other thing that we didn't mention before was that Spring Boot test is meta-annotated with Spring extension, which basically tells JUnit 5 to hand over control to Spring's test framework and start up the Spring application context as part of running the test. We want this to be a web, because we're writing a web application, we want to tell Spring Boot test that we want to start up a web application context. So we tell it that our web environment, that we're using a web environment, and we're going to say that we want to use a random port because we don't want any port clashes if we have multiple Spring Boot tests running. The other thing that we've been doing so far is we've been using H2 for the data JPA tests that we wrote earlier. And while that works at that layer, we want to make sure that the application works with the database that we're going to actually use in production, which is Postgres in our case, right? So instead of H2, we want to run our integration tests against a Postgres database. And like one of the most convenient ways to do that is using this project called test containers. We don't have that on our class path yet, so I'm going to go ahead and add it. So basically what test containers does is that it gives you, it runs your test and it starts up a Docker container as part of that. So basically you can stand up a Docker container for anything for which there's a Docker image. And the image can be from Docker Hub directly, or it can be one of your custom images. So once we've added these dependencies, let's go ahead and reload the project. And now we should have the test containers annotation, which will tell this is like test containers integration with JUnit 5 to stand up a Docker container as part of running this test. So once we have our test annotated with add test containers, we can get a handle on that Docker container using the add container annotation. And we're going to be using a Postgres container. So Postgres SQL container. And same Postgres SQL container. And here's the name of the Docker image that we wanted to start up. So we're just using the standard Postgres image from Docker Hub.
It's very confusing that the container Java object is PostgreSQL, but the Docker image is Postgres.
I know, which is why I kept typing that. Okay, so the other thing that we need is we want to auto-wire a test stress template. So this is another convenient thing that Spring Boot gives you when running a Spring Boot test with a web environment. And we can use it to actually make calls to our running server. So we're going to say that get cat by name returns cat, which is the behavior that we want. So this.rest template get for object to the cat's API name will give us a cat object, and the path variable will be Toby, of course. So this is going to give us a cat back, and we can add an assertion here with assert j cat.getName is equal to Toby. So that's pretty much what our application does. But before we even run this test, I think we need to tell Spring Boot to connect to the database that test container started up for us. And we're not doing that at any point. Like if you're familiar with Spring Boot and its database support, we need to set up some properties with the URL, the username, the password for Spring Boot to be able to connect to that data source. So we can do that using this app dynamic property source annotation, which is a really convenient way of setting this up, because prior to adding this support for this annotation, you have to do like this dance with application context initializers to get dynamic properties into the Spring environment. But we don't need to do that anymore with the help of this annotation. And it takes a dynamic property registry, which can be used to add dynamic properties to the Spring environment. Spring.datasource.url, and it takes a lambda, so it's a supplier. We can say db.getGDBC URL, and the same for username, password. And we need to set up one more property for the spring.jpa. Yep, there we go. And it's going to be PostgreSQL9dialect.class get name, is it?
Yep, but that's already a lambda. So you've got a supplier producing a lambda. You don't need both.
Thank you. Okay, there we go. So that's all we need to set up our integration test, right?
Yep, looks good to me.
Hang on, but we're saying we want to get Toby from somewhere, but have we even set up any data for our test?
No, not yet. So I've got my source test resources folder, and I'm going to create a new file called schema.sql. Spring Boot looks for these files, and it'll automatically load it and initialize whatever schema you want for you. So I'm going to create a sequence. Okay, so there we go. There's my SQL. Now I'm going to need some data. So I can create a SQL file called data.sql, which again, Spring Boot will run for me on my behalf. And I can just do, I'll go ahead and write some DDL to insert one record, our friend Toby. All right, that ought to do.
Yeah, looks good. Okay, so now that we've got these SQL initialization scripts, we need to tell Spring Boot to run these scripts, because by default, Spring Boot only runs these scripts, the schema.sql and data.sql, if it's an embedded data source. And in our case, in this integration test, we're not using an embedded data source. We're using an actual Postgres data source. So we will set this property to always. And because we only want it to be, we only need this property for our integration test, we don't need to separate it out into an application properties file. We can just directly inline it here in Spring Boot tests. Okay, so let's run the integration test. So the hope is that because we unit tested everything, the integration test should just work, but it doesn't. And it's because Jackson isn't happy with something.
Well, I think I have an idea. I think we need a constructor. I want to try that out. We can create a new constructor here.
Let's do it.
And I don't necessarily want that to be part of the public API, but if Jackson needs it, so be it.
So I'm glad we wrote this integration test, because even though our unit tests and our slice tests were green, there was something that they hadn't detected, which was something that Jackson needed, an OR constructor in our entity object. And there we go, our tests are green. And because we also made a change to cat, let's just make sure that all our tests are still green. typically you'd have a CI pipeline running your test suite. So even if you were to push this, before this code got to production, a CI pipeline would run all the tests and see if anything fails. Nice. So the whole thing is green.
Let's ask Angie.
Yeah, so testing is something that isn't traditionally taught in our, university courses or our boot camps. So it's a skill that a lot of developers lack. Fortunately, I've created a free resource called Test Automation University that is available online, testautomationuniversity.com. And there are courses for the various languages and frameworks. So you can learn about the testing mindset, how to properly test your applications at the various levels, whether that be at the UI or API or unit testing level.
Now, I'll work with Bella Bhave to learn how to introduce stateful database migrations with Flyway, particularly valuable in an immutable infrastructure-centric workflow.
Hi all, my name is Bella Bhave. I'm an engineer on the Spring Cloud commercial team at VMware. Since we're talking about a cat service here, let me introduce to you my two overlords who adopted me a few years ago, Chocobo and Paprika. Chocobo is more independent and she enjoys solitude unless she's looking for food. Paprika is a forever kitten. She seeks attention 24/7 even though she's already 4 years old, an adult cat. And she's sitting on my lap right now, so you will probably hear her or see her throughout my talk. Just like kittens can grow into adult cats and change their diet or behavior, software can grow too and may need to change data schema. Today, I will demo how to use Flyway to migrate data schema in a continuous integration fashion. Let's get into the demo. Let's say we want to know how old the cats are, so we need to add a field to track that. And of course, we don't want to miss out all the kittens fun, so we want to have age in month instead of age in years. Okay, after we added that, we need to make sure we add that to our database as well. And the initialization script, we can add some initial data to see that. Okay, I chose 4 just because that's how old Paprika was. She was 4 months old when we adopted her. And now we have age in month. Let's add some tests to make sure we can actually get that data back. We want to do get age in month. This time, let's call it Paprika. We can say maybe 9 months old. I don't know. How old is she right now? Too many. Can't count. Let's say 9 months old. And we want to assert that cat.get. We don't have a getter yet. Let's get a getter. Equals to 9. Okay, and now we also need a constructor. Age in month. We'll just use the other constructor name, and then we set age in month. Okay, let's run all the tests and see what happens. Yeah, they're all passed. Perfect. So let's start the app and pretend that we're actually running in production. We'll just leave it running throughout this whole demo so that we get the data persisted. So let me start the database and start the app using that database. And it's running. So let's go to here Look at this. Toby, age in month 4. We ship this code. All cats are happy. Except for 1 month later, they will come back to us and ask why aren't their age changing. We realized we made a mistake in the first place, that we should be storing date of birth instead of the actual static age. And now we're facing the breaking database schema change. But let's pretend that we don't know that the breaking database schema change will break production for a second and just get the feature to work locally. How do we do that? We can modify the cat class easily, just changing this into local date. We call that date of birth. And obviously it's not going to like that, so we'll just take in local date of birth and do date of birth. We want to keep the interface the same, so the cats will still know their age instead of their date of birth. So let's calculate age in month using date of birth. With today's date. Month. Okay. So that looks good. Well, if date of birth is null, then we might have an issue, but we can come back to this later. Hopefully we have a failing test somewhere to tell us, hey, you need to do a null check. Back to here, we have one related problem. Oh, right, because we're using that. So let's just calculate that also. Minus month, that's a really helpful method that I'm looking for. And run the test. Since we have a fully test-driven code base, we can just change it in the code and see what tests are failing to tell us what we need to do. And now we have a controller test failing. We got a null pointer exception probably because that, age in month, it's a null pointer exception. So let's add that null check here now that we have a test covering it. Date of birth is null, then let's just return null as age because we just don't know that mysterious cat's age. And there is another failure with integration test. What's wrong there? Get column doesn't exist, of course, because we forgot to change it here. So we want date. Actually, before I change that, I want to back them up. Because we know this is going to fail, right? Okay. Now we can change this. Type of date, and in the data here, we also want date of birth. For Toby, let's just use current date because that's just easy in the database. Okay, so let's run the test again. Yay, all green. Remember the assumption we made in the beginning that we can just get the feature to work first and worry about data migration later. At this point, when I see all the tests passing, I just want to run the app and see what happens, right? Because sometimes once you see all the tests green, you just want to ship it. And do we get lucky? Of course not. It failed to start because of the same reason integration test doesn't work. Date of birth of relation cat does not exist. So the new feature is ready to go, but the existing DB is not ready. Who should be responsible for the database migration? Should we rely on the DB admin to stay put and execute SQL queries at the exact same time when we swap out your production app? Yes, we should. Don't take me wrong, but not the human kind. Flyway can be that admin who lives in your code to perform that migration tasks. Flyway allows us to ship database migration scripts together with the application and run them automatically on startup. Flyway also keeps a schema table in the targeted database for applied migrations. So when your application restarts, it knows to skip the ones that have already applied. Let's see how that works in action. Let's add Flyway to our dependencies. Sure, right here. Flyway version is managed by Spring Boot Dependency Management, so we can just leave the version part out. We need to create a folder for the Flyway migration scripts. Flyway automatically look under this folder for the migration scripts by default. There is a property for using another location if needed. Let's just stick with the default for now. And now we need to create our migration scripts, and we have a new problem. What's the current database state? Maybe our application is running in a staging environment with existing database schema, but maybe it hasn't been pushed out to production yet, so the production doesn't even have that state. Now we need to create our migration scripts, and we have a new problem. What's the current database state? Maybe our application is running on a staging environment with existing database schema, but the production environment we have never deployed there before. The database is fresh, empty, brand new. So we want to make sure that we have some migration scripts that are only empty databases run to bring them to the same state as the existing databases. So the migration onwards are applicable for all of them. We can do that with Flyway by adding an application property called spring.flyway.baseline migrate. We can just set that to true. By default, the first version of the migration is the baseline itself. So for us, we can just move actually not this schema, but let me just delete these two now that we don't need them. We want to move this backup schema into this because that's the current state of the database in production or staging environment, whatever I say, doesn't matter. We can move the data in here too. So for an empty database, we'll start with these two, but for existing one, we skip that. And we want to rename this into V1. Let's just call it cat with age, because that's what the problem was. Okay, we no longer need the backup. And now we need to add our actual migration script that runs on existing databases. Just call it cat with date of birth. Okay, don't need that. So in this script, we want to alter our table cat to add a column date of birth with a type date. And then we also want to update our cat because our existing database already holds some data. We don't want to lose our precious cat's age, so we want to set date of birth with the data we know about the age using current date minus interval, say 1 month, multiplied by age in month. So with this script, we set date of birth with age in month. So we're not losing any of our precious kitten's age. And we can alter table cat again. It doesn't show me the catalog anymore. We want to drop the column age in month. Okay, so at this point, I think that's all the migration we need to do to swap from a age in month column into a date of birth column. You can run all the tests again. I have a typo somewhere. Yeah, cat. That catalog autocomplete is just horrible. Now the repository test and entity test are failing because something is wrong with our script. That's the second script we just added with the date of birth, interval 1 month type of operation. Just note that these two tests are supposed to be unit tests, and they're using H2 instead of the actual PostgreSQL. integration test is using the actual PostgreSQL. So I suspect that H2 doesn't support the date operation I have in that SQL query. This is an interesting problem for a lot of people because you might want to use the same database as your production database when you write tests, but you also want faster feedback. Using test containers is great for integration tests, but you don't necessarily need that in all your unit tests because for entity tests, do we care about data migration? We probably don't because we're just testing that the entity manager is doing what it should do, and that has nothing to do with database migration. Same thing goes to repository, that they should be very targeted and unit tests with very fast feedback. So yes, there are ways to make test containers to work with all those tests, but maybe for this case, we can just disable it in our test profile. And don't worry about that because it's still tested in the integration tests with all the migrations. And we're only disabling Flyway in tests. We're not disabling it in all our tests. Like, for example, integration tests still exercises data migration with the real PostgreSQL. So I consider that's covered. And now all the tests passed. And if we go to cat application, we used to fail to start, and we can start again and see if it passes. Yeah, it seems to be running. We go to Chrome and refresh. We still get Toby, and the data is successfully migrated. And with that, we have successfully introduced Flyway into our cat service. Database migrations are an important part in guaranteeing predictable upgrades across many successive rollouts. It's great that we can automate that. Thanks for watching.
Let's ask Angie.
So there's a lot of attention given to functional tests, and rightfully so, but there are non-functional areas that we need to focus on as well, such as security, accessibility. These types of things are extremely important, and yet they're often pushed off to the last minute, if done at all. So make sure that you include these non-functional areas in your strategy as well.
Now, I've got an idea for how to write a client and test it, but as we'll see when Olga explains, I'm clearly missing a step. All right, now that Madhura has built that amazing cat service, I'm gonna go ahead and build a quick client to talk to it. I'll use the web support. I'll use the stub runner jar because that brings in WireMock support. I'll open this in my IDE. Okay, so I have a cat client, and what I want to do is I want to go to the tests first and start running the test, and I'm going to use WireMock. So I'll say auto configure WireMock. I'm going to run against port 8080, and here I can use the API. I can say wiremock.perform or .stub4 wiremock.get wiremock URL equal to cat Toby, and this will return wiremock a response with this following body and with the following headers. Okay, so the body, of course, will be a string, so all right, and then I can use this here. And then the content will be, of course, HTTP headers dot application or dot content type. media type, application JSON. And of course, in order to do that, I'm going to use my client. And the reason we're going to build a client is because it's very convenient to have a sort of blessed client, a client that everybody else in the organization can use to talk to your service. And so, sure, they could figure it out. It is just REST after all. They could figure it out themselves, but why not just be able to package it up and distribute that and make that the canonical thing that people use? So we'll do that here. Okay, and here we're going to return a cat given a name. So say return this dot, and we need to actually have a type here. So we're going to create that type on the local machine, kind of DTO of the type. And we'll say get for entity HTTP localhost 8080 cat and then name cat.class, and that should do it. Oh, it's the other way around, isn't it?
Yeah.
Okay, so that'll be my cat client. This will be a Spring Bean, so I'll make sure that it's annotated as such. And in order to do my work, I will no doubt need a application context. So I'll go back to the production code and define a bean of type REST template. And then I'll go back to my test and I'll use it. This is the easy part, right? So I'll say this.catClient.find by name Toby cat result. I want to say assertions dot true result dot get name equals ignore case Toby. I could have probably just done equals, but it's a very simple example. And should have the correct name. So that seems like a reasonable example, right? I could probably use this. I don't even need that. So let's run it and see what we get. Cat client application test context loads. Great, it's all working, everything's fine. Well, I guess I didn't really need your help anyway, Olga. I figured it out by myself. Nothing's wrong. It's all green. Look at this.
You're ready to go to production.
Clearly, there's nothing that could go wrong here, right?
And what was the endpoint? Once again, where we were asking about the cat.
I thought it was cat / name.
What's a cat? Have you talked to the service team?
It's been a while,
Has Madhura put cat there?
She didn't put cat there, did she?
Let's check the code.
Was it cats?
It was cats, yeah. Oh my god, good that we didn't push it.
So it's green, but this still would have blown up in production, is what you're saying?
Yeah.
Well, there's got to be a better way.
There is a better way. We could have used Spring Cloud Contract to ensure that our steps actually meet what the server does.
What does that do? Can you show it to me?
Yep. This is our server, so as we see, Madhura put cats.
All right.
So that wouldn't have worked. Okay, I don't need all this. So what we can do is use Spring Cloud Contract, and this will create stubs that actually match what our server does. And first we need to add the dependency. And no, we don't want the integration test, we want the contract verifier, and we don't really want the version because it's from the BOM, but we can pass a scope. And one more thing that we are going to do is we will need to configure the plugin. But the good news is that if you get it from start.spring.io, you will already get the plugin setup done in the BOM for you with the defaults. And then, of course, you can play with it. So I'm just going to pretty much copy-paste the kind of setup that you would usually get. And we are going to be using JUnit 5 by default, but of course, you can also adapt it. So yeah, let's refresh it. And once this is done, what we can do is add our contract. We will do it under source test, resources, contracts. And let's add one new Groovy script.
So
And
you're using Groovy. Are there other contracts as well?
Yeah, we could use YAML and we could also use Kotlin.
Oh, cool.
And definitely with the code versions, it's easy because we get the autocomplete from the IDE. So let's do shoot, maybe return cat by name. Yeah, and now you can use contract make, and for any contract, HTTP contract, because we could have messaging, but that's not the case, we want to have a request and a response. Yeah, and then for the request, first let's say which method we'll be using. So in this case, we want to do a get, and then a URL, which was, I think, cats and Toby. So we are sort of hard coding it here, but of course later on you might also use wildcards and configure it in a way that it will react to different names, not only Toby. And then we are expecting to get a status okay, and headers. Yeah, we usually get some headers. Let's say I think we have a content type returned to us, which is application JSON, and then body. Obviously, it doesn't matter whichever order you put these elements in. What happened to the body? I thought that should just yeah, so this is it. We have our contract, and now we will be able to build it. However, we will also need to add something called a base class, and if you go back to the setup, it says the name for the base class here. Obviously, you can change your config, but the important thing is that the base class has to match whatever you have in your configuration. So the name and the signature has to be matching. And what the base class is, it is going to be actually a class that all the automatically generated tests that we will see in a very short moment will extend, and it will contain a base setup for our tests. And for this base setup, well, we could raise an entire application context if we want to, but a lot of times we just want to mock things out, because what we will be verifying with Spring Cloud Contract is our API layer and not really the layers that are below. So yeah, for the sake of this test, we will just create, because I'm going to use some auto wiring here, so I'm going to add a Spring Boot test, but you don't need it. You could even create your own objects as well. And we had a repository here, so I'm going to use mock bin to handle this. And let's say, because yeah, since it is an API test, I don't really want anything happening with any database while testing it. because I assume this is going to be tested elsewhere in my application, and I don't need this for my API checks. And now I'm going to outwire a service that we had. Yeah, and then I'm going to use JUnits before each to do some setup. So this setup will happen obviously for all the auto-generated tests. And what we are going to do is to create a sample cat, new cat. And what did we have to do? Name. Okay, let's give the name. It was Toby. And then I'm going to use Mockito to simulate that whenever I'm trying to get this cat by name, it will return this test object that we have created here. Cat. Okay, and this will be auto-injected with the mock bin. And now what we want to do is create our controller, and that's the main setup we are doing here. And for Spring Cloud Contract, we can use various modes underneath. A lot of them involve REST Assured, which is a library that allows you to verify REST interactions. And we are also going to use Spring Mock MVC for that in order to not to raise all the connection layer. So we are going to use REST Assured Mock MVC and standalone setup. So we will create our controller, we will instantiate our controller here. What was the name of that? Cat REST controller. And we pass the service. Yeah. So this should now actually work, and it should generate the stubs for us. But not only, it should also verify that the stubs are correct. And we'll see in a second how this is being done. So first, let's just run it. Yeah, so it passed, and you can see this is important, that it says that it is installing a snapshot with stubs to our local Maven. And we can also see these actual stubs. So let me show this to you. Let me refresh the view so we get to see the target. Yeah, it's here. And when we use Spring Cloud Contract, we will get the stubs under, we can view them under target stubs mappings. And this is an actual wiremock stub which was created for us based on the contract that we have provided. And as I told you, the fact that this stub is matching what our server does is being verified, and we can see it here. So when we go to generated test sources, we will see a test, and we haven't added this test. It was added for us, and as you can see, it extends the base class so to have some preliminary setup, and then what it does, it tries to run a call, same that we would do as it. Wow. It does a similar call to what we have prescribed in the contract, so actually exactly same request, and then it verifies that the response that we get matches all the criteria that we have specified. So basically it verifies that our endpoint really looks the way we say it should look in the contract. And just to prove you that this works this way, if we go to the contract and we do some strange thing, so yeah, we use an endpoint that is not really there and we run it, we expect it to fail. Yeah, so it did fail, saying that it got a 404. Well, of course it got a 404 because it doesn't really have a cut endpoint, and we are trying to do a call against a cut endpoint. But anyway, we already got our stubs installed the last time. We don't want to use just wiremock directly anymore. Instead, using the dependency that we already have, because we were using it, so Spring Cloud Contract stub runner, we were using it for wiremock. Since we now have actual contract stubs, we can just use this annotation instead, auto-configure stub runner. And what we need to do, it's pretty simple. We just need to pass the IDs for our server or producer side, so whichever group ID it has with the ID notation, and then the artifact ID. And then we want to get the latest version, and we want to run it at port 8080. So this is not the only way you can configure the port. You could also use properties or annotation, but here let's keep it simple. And a very important thing is the stubs mode. So we will want to keep the stubs mode local. It means we have the stubs installed in the Maven local on our machine. And whenever we run it, for example, in a deployment pipeline, we will usually get the stubs from an artifact repository where they would have been installed by a CUT server, so the CUT service built previously on this environment. So we would usually get it from there, but since it's now on our local machine, we need to set the mode to local. And now, so actually Spring Cloud Contract should raise the wiremock instance for us and already load the stubs, so we shouldn't need any other code. And now we can run the test and see what happens. Yeah, and it's green, and this green is a much better green than the previous green, because it means that our communication actually works. It is just not what we believe it to be. It is what really is there on our server side that we are verifying.
That's amazing.
Okay.
That's wonderful. I didn't know that there was a technology that could do that. That makes it much easier to be able to verify the integration between different components. I know that when I move to microservices, I have a lot more network interactions. I can't mock out my network service as easily and have the same confidence as I would with a mocked object in my code, because the compiler verifies the contract between the two. Now,
yeah, it's often a very different team working on it, and we really can't take their word on which endpoints are there, or they might have changed things. We never know.
Right. And things are going to change. You know, the software is moving quickly all the time. So you want some way to make sure that whatever's in production is what you're testing against, is what you're using.
Yeah. And you want to discover it in your deployment pipeline while running the tests.
And the best part about this is, just like with the wiremock solution earlier, because this is wiremock, the best part is I don't have to deploy the service to be able to test it. I can just deploy a mock API, so I don't have to deploy my whole Kubernetes cluster.
Exactly.
Now, this is great, but I want it, so if I deploy this to a pipeline, which I will surely do because we care about continuous delivery, I just switch stubsmode.local to stubsmode. What's the alternative for a pipeline?
Yeah. So as you see the stubs mode, you should use remote. You could also use class path, but that's not the case. So for your deployment, you would use remote.
Okay, I'll do that next. I'll add some settings to the Maven build to publish this to a artifact repository, and then we'll look at it in the next section. We'll look at how to set up a pipeline. Thank you so much for your help, Olga. I learned a lot.
Thanks.
Now that Olga has done all the hard work of making our client and our service integrate well, I do want to prepare this for use in a pipeline. So what I'm going to do is I'm going to change the repositories so that they point instead to a shared artifact repository, in this case Artifactory, and I'm going to set it up so that we also deploy to that artifact repository. The first things first, as I want to resolve dependencies in the client and the service, from the same artifact repository. So the first things first, I'm going to modify the build to depend upon a common artifact repository. So this part's easy. I'll just add this here to the bottom of the build. So I'll add in plugin repositories pointing to my Cloud Native Java JFrog artifact instance. And same thing I'm going to do for the repositories. So plugins and repositories will all be resolved through this proxy. Basically, all the requests will go to this, and it will in turn forward the requests to either the local Artifactory instance, the local JFrog repository, which contains some of my artifacts, or if it can't be resolved there, to one of the larger open sort of Maven Central style repositories. I'm going to do the same thing over here in the cat client. Now, I want to make sure that I can deploy these services to, so I'm going to bring in a plugin to configure publication to Artifactory. I've just pasted it in, and you can see it's just the JFrog build info Artifactory Maven plugin. It assumes a few environment variables, including artifact username, artifact password, and the GitHub run ID, the user, etc. We'll use these later on in the GitHub Actions environment. However, I also need to use this in the client. Both of these builds will fail because I haven't yet specified the value for Artifactory Maven plugin version. This is a property that I intend to keep at the top of the build, like so. I'm going to use Artifactory Maven plugin that version equaling 2.40. We should be able to go to our build and then run maven clean deploy and see this result in a build that gets deployed to an artifact repository. This can be very useful for sharing artifacts across different teams. We want to make sure that our service is publishing itself and its stubs to an artifact repository so that the client can then depend on it. There it is, deploying the artifact. You can see it's deploying the stubs as well as the jar. Now I'm going to change the code to resolve the stubs, not from the local .m2 Maven repository in my home directory, but instead from a remote Artifactory instance. And in order for that to work, I need to also tell it where to find the artifact repository. Well, as you know, I'm deploying everything to my Artifactory instance, the Cloud Native Java JFrog instance. So I will need to specify a repository root saying that it should go to cloudnativejava.jfrog.io/cloudnativejava lib snapshot local. With that, I should be able to also deploy it. Awesome. My tests on both sides have run. All the artifacts are now available in my artifact repository. I'm ready to move on to the next step.
Let's ask Angie.
I want you to ask yourself, is the customer going to use your machine? Of course not. We have to consider the various different environments and configurations, right? This is true on back end because there could be dependencies that you have locally that don't exist in production. It also matters very much so if you have a web app or a mobile app that you're trying to test, right? Especially a web app, because with the different browser flavors and oh my goodness, don't get me started on the different viewport sizes, those bugs just creep in there. So you definitely don't want to limit your testing to your local machine where you have the perfect optimal setup.
We've got a working service and a client, and it's time to test this automatically. Let's see if Whitney can help us make that happen.
Now that the cat service application is written and tested, what happens next? I'm going to show you how to automate testing using GitHub Actions. Then, if and when the tests pass, the tested code will automatically be duplicated to a repository called cat service release. Next, I'll show you how to use Kpack and cloud native build packs to automate a container image build anytime a change is made to the cat service release repository. Let's go. So what are GitHub Actions? GitHub Actions consists of triggers or events that kick off workflows. So how's this different from other software that does a very similar thing? Well, our triggers and our actions can easily be integrated with our GitHub repositories. So one trigger might be to whenever a pull request happens, it's going to kick off a workflow. And then that workflow will post a message to our team Slack channel that says, hey, yo, does anyone have time to do a code review? Or another one might be, maybe the trigger happens on a schedule. So every Monday morning at 8 a.m., a workflow is triggered and it generates a report of all the code changes that happened the previous week. And maybe that report, even as part of the workflow, can get emailed to the project manager. Our use case today is a very common one. We're going to automate testing that gets triggered by a code change. And only when that test passed does the code get promoted. And in our case, it's going to get duplicated into a separate repo called cat service release. So here we are in our cat service repository. We're on a branch called GA demo for GitHub Actions. And then the first thing we need to do is make a directory. So GitHub Actions is going to look for instructions in a directory, a hidden directory called GitHub, inside another directory inside that called workflows. And then I want to make a new file. And let's call it automate tests. So it should be up here. Beautiful. Here's our YAML. So the first thing we need to do is add the name. So we'll also call it automate tests. The next thing we're going to do is provide environment variables that can be used. They can be used at any part of our workflow. So these will be injected at every step. So we're giving our workflow a username and password for Artifactory and our Git username and password. Now Git secrets you can create once you're in your organization here. You can go to settings, scroll all the way down to the left to secrets. Then you can see we've created all the secrets here. So if you want to make a secret, you can create one. Ours will be called Cat Says and Her. And now I have a secret here. But what if I need to use that secret elsewhere and I'm like, oh shoot, I don't know how many R's I put on per. Let me check that out. Well, there's no way for me to look at this now that it's been made. It's encrypted and it cannot be recovered. So the only way to move forward with that would be to update the secret and enter a new value. So that's how secrets work in GitHub. And then we want to talk about, next thing we want to tell our workflow and tell GitHub Actions is what is going to trigger our workflow. So as we've already talked about, we want, anytime a code is pushed to our repository, we want that to trigger GitHub Actions. And for me right now, I'm only triggering it when it gets pushed to GA demo to our particular branch, so I don't mess up my friends who are also working in the repo. But I want to show some examples of what other ones look like. So if you wanted to do, a pull request trigger, it might look like that. Like we talked about before, it would trigger a message to Slack. We don't actually want to do that today, but that's what that looks like. And then we can also do a webhook trigger, which I think is incredibly useful. So that is called a repository dispatch. And then the type of dispatch can be anything you want as long as your call matches. So let's just show. So for example, this curl command would be what triggers cat meow. So you would have your GitHub personal access token in the header. It's a post request. The data is event type cat meow. So that's how it's matching it up to this trigger. And then the address is as follows. So we'll go ahead and leave that one in our, for funsies, let's leave it there. So now we're going to create a job. First, we're going to specify the build. So the build is, okay, a job is going to trigger what's called a runner. So a runner is a GitHub hosted VM that has GitHub Actions software already on it. So we're going to say that we want our runner to run on Ubuntu. And that's all we need to do to set up the runner. It can do Mac OS, it could do Windows, or it can do Ubuntu Linux. And if you want to use other operating systems, you can do your own, you can make your own runner. We're not going to get into that today. So the next thing we need to add is the steps. So we're going to do 4 steps today. So a step can either be a GitHub action. So in this case, this is an action, and a GitHub action can be created by people personally, but also they're more commonly going to use ones that are created by the GitHub community, because a lot of people are going to need to do it. Checkout, for example. We don't all have to write that code ourselves. So we're going to do a checkout action as our first step. As our second step, we're going to do a cache. So we're going to cache any built artifacts. So for our third step, we're going to set up Java 11. So we're setting up our runner machine right now. Our final step will be to automate the tests. So a step in a workflow, in a job, can either be an action, a GitHub action that looks like this, or it can be a command. And so we're doing a shell script here. So this shell script doesn't exist yet, so let's go ahead and create it. And so this is the full anatomy of our automate tests workflow. So now we want to add in that script. And this is what the crux of this is, that we are going to run Maven clean deploy, which is going to show all of our tests. And then only if our tests pass, then are we going to run this function promote code. And this function promote code is just going to nuke everything that's in the cat service release repo, and then replace it with everything that's currently in the cat service repo with what we know is a good working code that has just passed all the tests. So one important thing that I learned the hard way is that we need to change the permissions on any shell script that we give it. Beautiful. So with this, we should be good to go. All right, we're committing, and we're going to push it to the branch. That's a silly mistake. All right, so with that push, that already should have triggered our action. So let's see here. Oh yes, we have our action running right now. So we're gonna click into it. It says queued, so it hasn't quite started yet. It's setting up the job. So any of these we can click on them and get more information. It's going faster than me. So we're already setting up the Java 11 and now automating the tests. So as it runs through the tests, here is a good time to talk about the job in our workflow. So we're doing a job which is executing this series of steps, and a job gets a fresh VM every time a job happens. So you can put more than one job in a workflow, and if you don't specify otherwise, those jobs will run concurrently. But you can also specify for one to run after the other. Beautiful. So our build is successful. So now we should be able to go to the cat service release repository. Yep, and we can see it was just updated 14 seconds ago. We did that. Good job. Good job, everyone. So for funsies, so let's pay attention. This is 2968. For funsies, let's go ahead and run that curl command and see. So remember, what we just did is kick it off with the GA demo with a push to that branch. Now let's kick it off with our curl command to this repository dispatch. So curl command run, and let's see here, actions. Oh, I'm in the release. There we go, cat meow, it started a run. And that's how you can use GitHub Actions to automatically run your tests and promote successful code. Now that we can automatically run tests and promote our code, we want to be able to automate image builds. We're going to do that using Cloud Native Build Packs and Kpack. So Cloud Native Build Packs will take source code and consistently and reliably turn it into Open Container Initiative compliant container images. So it has three parts to it. The tool, so there's a pack CLI tool. There's also a Go library. And with these base tools, there have been tools like Kpack, for example, that are implementations of the Cloud Native Build Pack lifecycle. The lifecycle is the orchestration logic for how the container images are built. So that includes a build phase, detection, rebasing, analyzing, restoring, lots of different functionality within for how the image build gets done and gets updated. And then finally, we have the build packs themselves. And the build packs provide runtime support for applications, and they're a modular way of adding content and behavior into an image. So to get started, let's do a more manual image build by using a Spring Boot build image. So we're building an image here locally, and it's using the Cloud Native Build Packs and the Build Pack lifecycle. So you can see here that it's using Paketo Build Packs in particular. So Container Native Build Packs provide a unified standard to enable an ecosystem of open source platforms. And Paketo is one version of Cloud Paks. There's also Heroku has their flavor of Cloud Paks, as does Google offhand. One thing that's cool about Cloud Native Build Paks is a lot of the details about building your app are abstracted away, so you can focus on orchestrating the build. So here we are at successful, so let's see what we have here. So we can see our cat service image is here, and that's all we need to run our application. But we also, a builder image and a run image both got created. The builder is its own application that is building the actual cat service. And the run image is the image that is the base layer of the cat service that provides the environment. So we're using that pak command to be able to look more closely at our image, and then we can see what was used to make the images. So we can see all these Paketo build packs were used. So we need to recreate this on our Kubernetes cluster, and we're going to do that using KPak. KPak is a Kubernetes native build service that builds container images on Kubernetes using our cloud native build packs. It takes source code repositories like GitHub in our example, builds that code into a container image and uploads it to the container registry of your choice. So let's go to our cat service release ops repository. So I have drawn a picture to show what we need here. So right now we just need to build standalone resources for a store and a stack. So I'm going to go back to the YAML to show you more what that means. So the stack, the stack is what's going to provide our operating system layer. Let me see if I can remember the command. Pak stack suggest. So this is a handy dandy command that will show you some suggested stacks that are maintained by the community. So we can see Heroku has stacks on stacks, and then here are our Paketo stacks. So we want to replicate what we know works in Spring Boot. And we can see here that this is a minimal Paketo stack. We have a large Paketo stack, and we have a tiny one. So for our application, minimal seems excellent. So we're taking our stack ID from here, putting it into our YAML, our build image, and our run images both from here. The build image is going to have more functionality needed for that orchestration logic to actually build the image that won't be needed to run it. So this stack has already been created and applied to the cluster. Now we have our store stack, or not a stack, our store YAML. Our store YAML is letting our builder know what build packs are available to use to build images. So it's named Kubernetes Store, and we're using these particular build packs. So what we know is our application needs all of these build packs. So just by going to the repo for build packs Java, I can see that all of these build packs are included in that bigger Java build. And then I might also want to include build packs for other environments. Say my team also builds some Node.js applications, and we just want to have one builder that we can use for all of the images that get built on our cluster. So we can have it so our builder builds more than one type of image. So I keep talking about the builder. What is this builder? Let's go to my images. Our builder is going to use the store and the stack that we just defined. It's going to add in the registry coordinates for the builder image, and then it's going to add the detection order. And then this is going to make its own image on the cluster, and the builder is going to be used every time an image gets built. So what does that YAML look like? This is a Kubernetes builder YAML. Let's go ahead and name this one uniquely so we can apply it. So we'll call it Kubernetes builder Booyah. And it's in our KPAC namespace. We need to give it the tag. So the tag is our registry coordinates that we referenced in the image there. And then our service account is the way we're passing credentials to Kubernetes in order to access, to be able to push images to the registry. So our service account looks like this. We've made a service account called KPAC bot. So as you can see, it's already, SA is for service account. It's already applied to the cluster. And then we've created a secret in Kubernetes that's stored as, we called it regcred. And then the service account is connecting that regcred secret to the KPAC bot service account. And then in the builder, we're using KPAC bot service account to supply the credentials to our image registry. So this is the coordinates of where our builder will go. So we named it Kubernetes builder Booyah. We have the stack, the Kubernetes stack that we just talked about, and the Kubernetes the store we just talked about. And then this detection order. So detection is one of the phases of the Cloud Native Build Pack lifecycle. And when during that phase, it's going to take the build pack group and it's going to check whether that build pack group is compatible with the source code. So in our pretend company, we make mostly Java applications and just a few Node.js applications. So we want our builder to look for Java first before Node.js as a matter of efficiency. So with all of that information supplied, we can go ahead and apply it to our cluster. And there we go, we created it. Now, we can watch here, this is what's in our registry right now. We can watch here, and our Kubernetes builder Booyah has been built. So now we have a builder ready to go. So finally, let's go to the images. Finally, we're going to make an image spec. So we're going to give the information about how we want our image, our application to get built. So we're going to supply the registry coordinates for our application image. We're going to need to supply that service account again if it's not public. We're going to supply our builder that we've already made. And then we're going to tell it what source we want it to watch in order to automate our image builds. So with that in mind, let's go to our KPAC image YAML. So we're naming, it's named cat service. Let's go ahead and make it cat service Booyah so we can distinguish it. And then it's going to use the Kubernetes builder Booyah. And it's worth mentioning that the builder we created is a kind builder, which it means it's namespace scoped. So it's possible to make a cluster builder, and then anything that gets built on the cluster can use that builder. That means giving your credentials differently, so it can access it from any namespace. But we're just using a namespace scoped builder. The service account we already talked about. The cache size is optional, but we're giving it so if you don't include it, the caching feature is disabled. Now here's the source. We're using a Git repository as our source, but you can also use a registry or you could use a blob. With our Git repository, basically we're telling KPAC that we want it to watch the cat service release repo, and if that ever changes, we want it to trigger an image build. Interestingly, it's also watching the stack in the store. If anything changes in either of those, it will trigger a new build, a new builder build, and a new image build. We're going to call it cat service booyah. And then these are Open Container Initiative labels that we're including here. So let's go ahead and apply our image. And I don't know whether that is going to make it build one automatically, or whether it has to be triggered by our code. I think we'll find out. We'll find out together when we trigger. So we're going to trigger our code, our rebuild, by changing our code. So when we do that, if there's two cat service booyahs, then we'll know that the application of the YAML triggered one. But if there's only one, then we'll know it only got triggered by the code. So it's an adventure. So let's bump our code and see what happens. So we're just gonna bump it. This is a little tedious. I apologize in advance. It doesn't like that second. There we go. And then we're still in the GA demo names branch from earlier. Beautiful, we bumped it. Now I have this going on, so we should be able to watch things happen. So let's see. Still no cat service booyah, so I think it didn't. Applying the image YAML didn't make an image. So here we are watching our pods in our KPack namespace. And then we also see that our bump triggered a build. So we can watch this build go. And when this build completes, we should be able to see pods start to spin up in the namespace. So another cool thing about Cloud Native Build Packs is they're unified standards, which enables an ecosystem of build packs and tools, which you may have been able to infer just by seeing when we looked at that stack command, for example, that Heroku had possible stacks. Tanzu Build Service does a stack. If you don't want to build on Ubuntu, they have more operating systems, for example. Cloud Native Build Packs also optimizes the image building process for really fast rebuilds. Aha, we're done. So the rebasing just changes a metadata instead of having to build all the layers on top. But let's, so that completed job. Yep, there we go. Beautiful. Oh, that feels good. So now we have our build pod. These are build pods, as you can see. I refreshed this just to see whether we got a cat service booyah, and we did not. So our builder is spinning up these build pod jobs for the different phases of the Cloud Native Build Pack lifecycle. So now we can watch this go through, and then when it's complete, we should be able to refresh our container registry and see that a cat service booyah has been built. So let's talk more about the rebasing. The Open Container Initiative has a metadata layer that points to all the layers, metadata document that points to all the layers. And when a rebase happens, just the metadata for a layer needs to be rewritten. So it happens really quickly, as opposed to back in the Dockerfile days where you would have to rebuild everything on top of the layer that was getting updated. Not to mention, you would lose all the caching that you had. Okay, it says, is it completed? Completed? Cat service booyah! We did it together. What a team. So there's our image automatically built on the cluster. When the cat service release source code changed on GitHub, it triggered that. And it uploaded the results to our container registry. This has been fun.
Let's ask Angie.
So there are different ways that you can test your application at different levels. So unit tests, I recommend this be your largest set of tests. And this comes from the Testing Pyramid by Mike Cohn. Unit tests is where you focus a lot of your energy because these are cheap to write and to execute. Then you want to test the integration level. So, different features or components that are integrated together, you want to make sure that that integration works, right? And then you have the final layer, which would be your UI layer. So if you're working on something that's, a web app or mobile app or something like that, you want to definitely test the customer experience as well.
This is awesome. The only thing I want is a smooth ride onto Kubernetes. This is squarely the work of a continuous delivery pipeline. And who better to explain that than Cora?
Thanks, Josh. Okay, so we've watched Toby go from a baby kitten, passed all these tests and became a mature cat. And now he's ready to be catapulted into the wilds of Kubernetes where the big cats and the catamounts roam. So we're going to help get him there. In this segment, we're going to employ the methodology of GitOps, and in particular use Argo CD to automate the process of deploying our application to Kubernetes. So one great place to start is this website called gitops.tech. And as it says here, it aggregates the essence of GitOps to help clear up confusion. So let's start by focusing on this particular sentence right here. The core idea of GitOps is having a Git repository that always contains declarative descriptions of the infrastructure that you desire and an automated process to make the environment match the declared state. So we have a few pieces to put together. We're going to need to have our Git repository that's going to be GitHub, and we're going to put our declarative descriptions there. Those are going to be our Kubernetes manifest files. And we're going to have to automate the process of making sure that what's in the cluster is always what's in those files. And for that, we're going to use Argo CD. So let's head over to GitHub. So here in GitHub, we've got a manifest directory. So these are our YAML manifests, our declarative state. And you can see here that we've, for simplicity, we've placed both the application and the database in here. Both the application and the database have the expected deployment and service YAML declarations, nothing out of the ordinary. And in the case of the application here, we've also included the application properties from the Spring Boot main resources directory, and we're relying on Customize to generate a config map out of that. So it's going to take this file and generate a config map. Also update the tag of the image to latest. So as you can see, we're using this tool called Customize to help compose the YAML. You can wrangle your YAML any way you want. It's bound to become a cat's cradle anyway, I think, but we try. So those are our base files. And then we hop over to the overlays, and we're going to go into the prod configuration and look at that customization. And so this one is basically saying, grab everything in that base. So get the app, get the database files, and make a few modifications, make sure that the namespaces are all set to prod, that all of the resources have a prod prefix, set the replica count to 1, for example. And for the purposes of our demo, we've also added here another configuration map being generated by Customize. This one is not used by the application, but it will be used by us in the next few minutes. So this is just catty config with a literal value, kitty equals cat. So we've got our declared state and it's stored in GitOps. So we're halfway there. We need to automate the process of applying this and kind of ensuring over the life of the application that whatever is in the cluster matches what's in the manifests, because those can diverge. Now, let's head over to Argo CD. So we'll sign into the UI. So this is what the UI looks like. There's no application yet, so there's not that much to look at. Of course, we could create the application here. And if we were to do that, we would set the key pieces are the source. So basically, where does Argo CD go to find the YAML manifests? So that would be our ops directory, our ops repo in the manifests overlays prod directory. And then the other question is, where do I apply this to? What cluster, what namespace? So, and then there's some different options you can set to either be automatic or be manual. You can see the defaults here are generally manual. So let's cancel this and let's do the same, but we're going to do it through the CLI. So here you can see kind of the same concept. So we're going to say, create this app. We give it a name. So where are the ops files coming from? So we say, this is our repo that has our manifests. We're getting them from this particular branch, and we want to get the overlay for prod in particular. And then where do I deploy this to? This is here. It says basically deploy it. This is how you specify to deploy it to the same cluster that Argo CD is running on into the namespace called prod. And as far as extra policies, I'm only going to grab this one. I'm going to leave the auto prune out. And basically this is saying automatically sync. So anytime that there is something in the manifests that changes, automatically apply that to the cluster. So let's go ahead and run that. Okay, so our application is created. We can see it in the CLI actually with Argo CD app list. Make sure that it's there. And we can see that it is synced and the health is progressing. Let's go over to the UI. And again, same information, it's synced. Synced means what's in the cluster matches what's in the manifests. Progressing means that things are still starting up. So if we log in there, we click in there, you can see that it is this application that the Prodcat service that is still in the process of starting up. You can check that in get all -n prod as well. Let's see how it's doing. And actually, it's fine. The reason that happened is that this the cat service actually has a built-in delay. It takes a little bit of a cat nap as it's starting up because it's been configured to have a delayed start so that it allows the Postgres database to start up. So, or actually the app starts up, but what we've delayed is Kubernetes restarting it because it doesn't start up successfully quickly enough. So, all right, so everything is good. And in fact, if we go back to the UI, it should all be healthy. Okay, so it's all healthy, it's all synced, everything's good. Now, what happens when there is a change to the manifest? So let's go ahead and try that out. Let's go ahead and say we want 2 replicas of cat. And we want to delete this config map that we don't need. And just to make it more clear, we'll do a get config map and pods from the prod namespace. Before we have the prod caddy config, and we've only got one instance of the cat service, right? The other one is the database. So we were going to want 2 services of the database, and we want the config map to be gone. So let's commit that. Now, Argo CD may take a minute to realize that. Let's actually speed that up. Okay, so it's realized it's out of sync, but then it's immediately increasing. It applied the YAML, right? And it applies the YAML because auto sync has been enabled. because we set that as a default. However, the configuration map exists in the cluster, but it no longer is in the manifest. So deleting a resource from the cluster that is no longer in the manifests is not part of the sync. It's actually part of a process called pruning. That's what they call pruning. So it won't automatically prune if you don't have auto prune enabled, which we don't. So in this case, we are going to prune it manually. But the important key here is to recognize that there's a difference between applying YAML and deleting a resource from the cluster that is no longer in the YAML. One is called syncing and the other one is called pruning, and they can be configured separately from one another. Now, the last thing that I want to show you is something called self-healing. Now, there is a level of self-healing that happens within Kubernetes automatically, right? If you do, for example, as we know, if you have a deployment, the deployment creates a replica set, and the replica set makes sure that you have enough replicas of what you want. So, for example, our deployment for cat service has created this cat service replica set, which knows we want 2 pods. And so if I delete a pod, the replica set will make sure that it gets recreated. So that kind of self-healing is kind of self-contained within Kubernetes to that deployment. But what if I delete the service? Or what if I delete the deployment itself? There's no mechanism to recreate them, as you know, because really the assumption is that if I issue this command manually, delete deployment. If I issue that command manually, I probably intended to, so there should be no process within Kubernetes to say, hey, no, I'm going to recreate it. And you might not want it to, right? There could be situations, for example, in production where you have to take some kind of emergency action right on the cluster, right? Say someone cat burglars their way into your cluster and has some ill intention, wants to cause a catastrophe, and you want to avoid that, right? So you might take an emergency action and you don't want Argo CD to overwrite it immediately. So that self-healing at that higher level, it can be automated, but by default it's not. So in this case, what's happened? Let's see. Again, Argo CD realizes that it's out of sync, and it is the deployment that's out of sync, and it's the health of it is actually missing. We can see the same thing at the CLI. And we see that it's out of sync, the health information is missing. And so what we can do is sync it. So in this case, let's just do it from the CLI, Argo CD app sync, and it's the prod cat service. Same as clicking the button on the UI, and it's going to fix our problem. Let's check k get all minus n again. Oops, minus n is prod. And you can see our cat service deployment has been recreated and the apps are starting up. So it's getting there. We can refresh this. The pods are starting, but it's replaced the deployment. So it reapplied the manifest when we told it to self-heal. So those are the 3 key concepts I wanted to show you: syncing, pruning, and self-healing. So as you can see, whether there's a change to the manifest, Argo CD can apply it. If there's ever a situation where the cluster is out of sync with the manifest, Argo CD will notify you, and given enough freedom and permissions, Argo CD can automatically correct that situation for you. So that completes the GitOps setup for cat service. Back to you, Josh.
Let's ask Angie.
I often say that if your tests are going to be a part of continuous integration and continuous deployment, then there are extra considerations that you need to make. This is the big stage, and your tests have to be ready for it. They can't be flaky. You need to consider speed. How fast are your tests? Because the whole point of CI/CD is to give some fast feedback. So you want your tests to run very fast. Another consideration is the reliability of these tests. Again, they cannot be flaky. You don't want your deployment to fail because of an unjust cause. Likewise, you don't want it to pass when there's really a bug there. So you have to make sure that those tests are super reliable. Also, you need to manage the test data that you're using. Make sure that you have this data in a state that is reliable, that it's not going to affect anything if your tests are running in parallel or anything like that. That's super important. Also, the quantity of tests. You don't need to automate the test for everything. That doesn't mean you get off the hook for testing it, but it doesn't necessarily have to be automated. The question I like to ask myself is, if this test failed as part of CI/CD, would we still deploy? And if the answer is yes, then maybe that test isn't a good fit for continuous integration. And then also, this is one that people often forget. It's the maintenance. Definitely factor this into your plans. As your application is evolving, your tests need to be maintained to match the current state of the application. So be sure to allot time to handle this.
Sadly, all good things end, but not before our architect extraordinaire, Nate Schutta, gives us the last word.
As usual, we've covered a lot of ground today, but I think it's worthwhile for us to take a step back and just look at how did we get to where we are. I've been in this industry a long time, and I remember when I first started, software was a very siloed game. We were all in our own little parts of the organization, and never shall we mix. Many of you, I'm sure, remember waterfall, where one phase flows into the next. We would spend months sometimes gathering requirements, and then we'd go and do design, and there'd be the build phase and the test phase, and then software would enter the maintenance phase, where it would live for the majority of its lifetime. And I guess this worked, for some definition of worked. But of course, during this phase of software, our teams are very separated. It was as if we were all in a little bento box and we weren't allowed to mix with one another. And business analysts did their thing. And then we went off and developed some stuff. And then the testers told us we did it wrong. And we did a little dash of UI to make it look pretty. And then the operators and our infrastructure people would complain that we brought prod down again. And of course, during this era, we didn't really work well together. Unfortunately, there was often a lot of animosity between groups. It was borderline trench warfare in many organizations. Often it was very common for us to have one-way traffic for handoffs. I would hand it to you and you would hand it to someone else and do your thing. And this was usually scheduled and it was limited to just a few instances a year. Or to put it another way, you just throw it over the wall at QA. Throw it over the wall, it's infrastructure's problem. And that was a very common thing for us to say. And of course, that didn't always work well. Again, we didn't always work well together, much as this tweet shows. We're trying to break this glass. All right, someone just throws a sledgehammer at it. I guess that sledgehammer solves a lot of problems, apparently. Of course, during this era of software, there was a lot of finger pointing. We'd get a defect and we'd say, no, it works as designed, or unable to reproduce. And our infrastructure people would yell at us saying, you brought prod down again. And we just, wash our hands of it and say, hey, my job here is done. Now, this isn't an ideal way to work. Of course, during this era of software, our cycle times were measured in astronomical units as if we were turtles walking along the beach. But you know what? Eventually, code did get to production. But you realize very quickly that that's not the end of the road, is it? No, the reality is code spends 90% of its life in the maintenance phase. Someone told me that when I was learning about software engineering. And of course, what you realize after a while is, it's not really true. It's more like art. It's done when it's abandoned. Now, I do think we've made this transition from project thinking to product thinking. And I do think that that's an important way of looking at software. But the reality is the world doesn't stand still. Our business cycles keep speeding up. We have to adapt. We have to embrace this always be changing mindset. But how do we do that as software engineers? How do we move fast safely? It can't be bespoke. It can't be artisanal. It just doesn't work. I mean, it never really worked, honestly. I mean, let's be clear. People aren't capable of doing the same thing twice. If you don't believe me, take up golf as a hobby and get back to me. The reality is we all have bad days. We get bored. We skip a step. We fat finger a command. We send the integration test email to millions of subscribers. Oops. Yes, please, just breathe. It'll be okay. We've all done something stupid. That actually would be a very cathartic thing for many of us to admit this was the silliest thing I ever did. I mean, we all have those stories of wiping out a hard drive, dropping a prod database, et cetera, et cetera. The thing about computers is they don't do that. Computers don't ever get bored. It turns out they're really good at repetitive tasks. It's almost as if they were made for that. And I learned a long time ago that in computer science, there's really only 3 numbers. There's something you do 0 times. There's something you do 1 and only 1 time. And then there's n. If you do something more than once, you're going to do it 1 billion times. And the reality for us is anything we do more than once needs to be automated. We need to offload that to the computer, make the computer do that work for us, because that gets us consistency. Now, another way of phrasing this is we need to shift as many things left as we can in the process. And what we really mean by that is let's catch the mistake as soon as we can in the process, and let's correct it when it's the cheapest to fix. Let's not wait until the mess gets so large that the best option is just nuke and pave and start over. You know, why do we all love Greenfield so much? Well, because there isn't a mess, not yet. Now, I do think part of the contributing factor here is many of us have managed to move on to new projects quickly enough that we haven't had to deal with our own messes. You know, being around a project long enough to have experienced the consequences of your decisions is a very, very good thing for engineers, especially if you want to become an architect. Now, the beauty of these distributed architectures is we have a lot of freedom. Now, of course, we must never forget Uncle Ben's wise words, with great power comes great responsibility. And I'm a huge fan of independent life cycles. I think that's a big win for us. It gives us improved speed to market. It gives us increased developer productivity. I've been on a lot of monoliths, and those getting started guides are usually the size of a dictionary. The build times are measured in phases of the moon. It can take months for a new developer to get up to speed. On these smaller, finer grained things, it's less for me to get my head wrapped around. Builds finish quickly, which means that build breaks are fixed promptly. You're not in a situation where, well, wait, I broke the build on Tuesday. I didn't find out till Thursday. I don't remember what I was doing on Tuesday. It can be a lot easier to test in these environments. I was on one project and I made a suggestion and my test lead just glared at me. And I said, you have some input. She said, please don't make that change. I said, why not? She said, if you make that change, I have to spend 80 hours doing a manual regression test. You know, in these environments, we can run fine-grained tests that execute on every commit. We can actually do performance testing on a regular basis instead of as this one-off thing we do occasionally and then just throw in the drawer because we can't do anything about it. We can bring the right tools to bear. The problem with these shared life cycles is we're at the mercy of whatever our slowest moving piece is, whatever that longest tent pole is. The beauty of distributed architectures is I'm not forced into this one-size-fits-none approach. And if you've ever gotten a shirt at a conference that says one-size-fits-all, you might be like me and wonder, who is this all person? Because it isn't going to fit me. In this approach, every service can use the right mix of tests that make sense for it, the right set of linting rules, code quality scans, can be a lot easier to find fitness functions. I can actually practice hypothesis-driven development. At the end of the day, what customer of yours doesn't want a constantly improving product? More to the point, what company doesn't need a constantly improving product? Now, I'm a huge believer that independent life cycles are an underappreciated benefit of these approaches. We have to understand that that's how we've always done it. It just doesn't work anymore. We have to do better. We have to move fast. We have to do that safely. That only happens with automation. At the end of the day, we should be judged about getting features and functionality to production, and we need to be able to do that reliably and repeatably. The one constant is change. That's not going away. We can't fight that. We have to embrace that. And so we need to do everything we can to adapt to that world and make sure that our systems can survive in this constantly changing environment. Now, it's not easy, but hopefully what we've talked about today will help. In the meantime, thank you very much for your time and attention. I appreciate it. Good luck. Godspeed. We'll see you soon. Cheers.
Thank you all for watching. We hope you enjoyed it. It's been a lot of fun for those of us on the SpringOne Tour team to produce it for you. As always, we're on YouTube, so spring.io/video. And you've seen all of our Twitter accounts. We'd love to talk to you and engage and carry the conversation forward. We want to thank you for your time, and also Don't forget, if you like this, you should definitely register for our annual tentpole conference, SpringOne.